Welcome to the Non-Destructive Testing and Evaluation course. The course code is ME8097 for the regulation 2017. So here in this video session, we'll be studying about the magnetic particle testing in Unit 2. So magnetic particle testing, we have this following syllabus: theory of magnetism, inspection material, magnetization methods, interpretation and evaluation of test indications, principles and methods of demagnetization, and residual magnetism. So coming to the introduction of magnetic particle inspection. So normally magnetic particle inspection is governed by the laws of magnetism, and hence it's restricted to the inspection of materials that can support magnetic flux lines. Normally, metals can be classified as ferromagnetic, paramagnetic, or diamagnetic. And this ferromagnetic metals are those metals that are strongly attracted to the magnet and can be easily magnetized. Examples: iron, nickel, and cobalt. So, such kind of materials can be tested by using this magnetic particle inspection. And paramagnetic metals such as austenitic stainless steel are very weakly attracted by the magnetic force of attraction and cannot be magnetized. Example: aluminium. Diamagnetic metals which have a weak and negative susceptibility to magnetic fields. Diamagnetic materials are slightly repelled by the magnetic field, and hence the material does not retain the magnetic properties when the external field is removed. Example: copper, silver, gold. And hence the magnetic particle inspection is not applicable to non-magnetic materials. So the only requirement for the inspection through this technique is that the components being inspected must be made of ferromagnetic materials. That is, the materials should be magnetized, like iron, nickel, cobalt, and some of their alloys. The method is used to inspect a variety of product forms, including castings, forgings, and weldments. So many different industries use magnetic particle inspection, such as structural steel, automotive, petrochemicals, power generation, and aerospace industries. And underwater inspection is another area where magnetic particle inspection may be used to test offshore structures and underwater pipelines. So magnetism, introduction to magnetism is in this way we are going to study about how the magnetism is magnetic lines of force or form, right? So magnetism is the ability of a matter to attract other matter to itself. So the objects that would possess the property of magnetism are said to be magnetic or magnetized, and hence the magnetic lines of force will be found in and around the object. And this magnetic pole is nothing but it's a point where a magnetic line of force exits or enters a material. And here in the diagram, you can see the magnetic lines of force around a bar magnet. You have a north pole and the south pole of the magnet. And you can see the magnetic lines of force moving in a circular loop from one pole to the other pole. And the second figure, you have this north pole and south pole. That is, opposite poles attracts each other. And you can see the magnetic lines, how they behave. And the similar poles repels. When you bring similar poles, there is a north pole towards the north pole. So you can see there is a repulsion between the two magnets. And normally this magnetic field lines forms a complete loops, and they do not cross over. And all have the same strength, and they have a direction such that they cause poles to attract or repel each other. And ferromagnetic materials. So a material is said to be a ferromagnetic if it can be magnetized. And you have this example: iron, nickel, or cobalt are generally ferromagnetic materials. So ferromagnetic materials normally are made of many regions in which the magnetic fields, so if atoms are aligned, these regions are called magnetic domains. And here the magnetic domains randomly in demagnetized material. See, you can see the first figure. It's a demagnetized but can be aligned using electrical current or an external magnetic field to magnetize the material. So to magnetize the material, you require an electrical current or an external magnetic field. So once the material is magnetized, you can see the magnetic lines of moving in a circular loop without any breakage or without interruption. They don't cross over. So how does a magnetic particle inspection work? So a ferromagnetic test specimen. Here you have the first figure, you have the material that is to be tested, which is placed below the permanent magnet. You have a north pole and the south pole. So a ferromagnetic test specimen is placed beneath the magnet and it is magnetized with a strong magnetic field created by the permanent magnet or by using a special equipment. And if there is any discontinuities, so this part is being magnified here and you can see the crack or the discontinuities in the test specimen. And if any discontinuities present, you can see that there is a flux leakage. You can see there is a flux leakage through the specimen, and the leakage field will occur. That is, where there is a crack, you can see the poles has been changed. For example, the right side of the test specimen, you have the south pole, and at the crack part, it has been changed to the north pole, and the corresponding side has changed into south, and the left side it is north pole. So you can see there is flux leakage in the test specimen where there is defects. So from this you can identify the defects. So how does magnetic particle inspection work? And this is a continuation of that. You can see the test specimen is here, and initially it is magnetized, and once the test specimen is magnetized, magnetic particles are sprayed above the test specimen, and due to this discontinuities in this magnetic lines of force, the particles are attracted to the leakage field and will cluster to form an indication directly over the discontinuities, and this can be visually detected and proper lighting conditions. Likewise, you can find out the crack. So advantages of magnetic particle inspection: it's very fast, simple, and inexpensive. It's this method of testing is a direct visible indication on surface, and it's unaffected by possible deposits, example oil, grease, or other metals chips in the cracks. And this can be used on painted objects also. The results readily documented with the photos or tape impression, and post cleaning generally not required. Relatively safe techniques. Materials are generally not combustible or hazardous, and the relative size can be indicated and the shape of the discontinuity. Easy to use, and it requires minimal amount of training for the tester. And it also has limitations. The magnetic particle testing, here non-ferrous materials such as aluminum, magnesium, or most stainless steels cannot be inspected, and the examination of large parts may require use of equipments with special power requirements, and may require some removal of coating or plating to achieve desired result. And there is some limitation in the subsurface detection of discontinuities. And the limitation is post demagnetization is often necessary. That is a limitation. And the alignment between magnetic flux and indication is very important. And each part has to be examined in two different directions, and only small sections or small parts can be examined at one time. And coming to the applications of magnetic particle inspection, using this magnetic particle inspection techniques, you can detect both surface and near subsurface defects. And you can inspect parts with irregular shapes easily. And here this pre-cleaning of the test specimen or the components is not as critical compared to the other inspection methods. And the low cost, the cost is very low compared to other testing methods. And this testing magnetic particle inspection equipment is portable inspection method, especially when used with battery powered equipments. So with this we come to an end for this magnetic particle testing. So thank you and have a great day.